Hi folks, today we're going to look at three different three-dimensional objects. We've got a cylinder, a sphere, and a cone. This is a cylinder. And this is actually a prism. It's a circular prism. So we're going to use the same formulas we use for a prism. The sphere is the easiest one because it's only got one dimension. We only have to worry about the radius. The cone is probably the more complicated one. We've got a radius, we have a height, just like we did on our cylinder, and then we've got what's called the slant height. So I'm going to go through an example of all three, and I'm going to use a similar radius so we can kind of compare it. So my radius on my cylinder is going to be 5, and I'll go ahead and use a height of, let's go with 10, I guess. This one's also going to have a radius of 5, so we can compare them. So let's go ahead and do our cylinder. Remember that we can unroll this thing where this distance is the circumference. There are pi diameters or 2 pi radii on this side. This is the circumference times the height, and that gives us our lateral surface area, which happens to be 2 times pi times 5 times 10, or 100 pi. This is in square units. Not too hard. We also have a top and a bottom. We call these our bases, and they are pi r squared, in this case 25 pi and 25 pi, and our total surface area is the sum of everything. So 100 pi plus 25 pi plus 25 pi makes 150 pi. Now, this is an exact answer. This is assuming that it's possible to have a cylinder that has these exact measurements. In the real world, that's not possible, and we always use more or less an estimate, and we could use 3.14. If we use the pi key, it's going to be even more accurate. So it's going to be somewhere between 450, 460, something like that. I can go ahead and put it in. This is 150 times pi, and we're going to get about 471. This is actually accurate all the way out to here. If I use 3.14, it would only be accurate to 3 places. Anyway, there it is. That's the surface area. The volume of any prism is always the area of the base. In this case, it's pi r squared times the height. Well, if I take pi r squared, that's the area of the base, 25 pi. 25 pi times the height, which is 10, and I get 250 pi, and this is in cubic units. This is an exact answer, and if I want an approximate one, I could just put it in 250 pi into my calculator and get an estimate. The sphere is a little bit easier, and the way I remember the surface area is really easy. I think of it as 4 circles. And one way to kind of remember it is that if you think of a baseball and you take off the stitching, what you end up with is 2 pieces that look something like this that are stitched together. And then there's another piece, that's kind of similar. Anyway, when they stitch all these together, they get a baseball. And that's how I kind of visualize my 4 circles. So the surface area is exactly 4 pi r squared. And in this case, we're looking at 100 pi. Interesting that the 5 squared gives me the 25 pi times 4, and it just so happens that this one and this area is the same. Kind of odd that it worked out that way. That was just, just a coincidence. The volume, of course, is a little different. It's 4/3 pi radius cubed. And if I cube the radius, I get 125. So 5 times 5 times 5 is 125. I'm going to multiply that by 4, and 4 times 125 is 500 pi over 3. Now, this is an exact answer, and this is in cubic units. And again, I could put this in my calculator and get an estimate. This 4/3 is really important. If you're going to use a calculator, make sure you put it inside parentheses. And if you use 1.33, remember it needs to have more threes if you want to be more accurate. Finally, there's the cone. The surface area of a cone seems to be one of the easier ones. It's a little harder to explain why, but it's pi r h. That's it. Pi RL, excuse me. This is the slant height of my cone. So it's pi times radius times the slant height. And we could get into the reasoning, but it's really complicated. I'm just going to go ahead and put the numbers in. My slant height for this one would be really tricky, especially if I leave this at 5 and this one at 10. Then my slant height is going to be the square root of 125, which reduces to 5 root 5. 5 root 5. Anyway, this is the square root of 125, which is really close to between 11 and 12, a lot closer to 11. It's a little bigger than 11. The way I got that was I used the Pythagorean theorem. A squared plus b squared equals c squared. So 5 squared plus 10 squared is equal to my hypotenuse, which is that L. And then I get 125 is equal to L squared, take the square root, and L is the square root of 125. If I reduce this by taking out the 25, I get 5 root 5. If you don't know how to reduce radicals, you might want to practice that a bit. Anyway, the surface area is going to be pi times r. R happens to be 5. And the slant height is 5 root 5, or the square root of 125. What'll happen is in a test or like a SAT or something, they're going to reduce it. So there it is. It's going to be, I'm going to go ahead and put it in order. 25 root 5 times pi. And you could put this in your calculator and get an estimate for that. The last thing is the volume of a cone, which is really interesting to me anyway. It's a lot like a pyramid. It's 1/3 of the volume it would be if it was a cylinder. Since this is the same size as this cylinder, it would literally fit inside of it, just like this. That would be my cone. It has the same height, it has the same radius, and it's going to have the volume that's 1/3 of this cylinder. So it's 1/3 pi r squared, that's the area of the base, times the height. And in this case, I've got 1/3 times pi times 5 squared times 10. This is going to be 250 over 3 pi. 250 pi over 3. That's the way we would write that. And that's in cubic units. Hopefully you got a little bit out of it, and I tried to make it kind of quick so you could kind of see these 3 different objects and how to find the surface area and the volume. Hope it helped. Have a nice day. Bye, guys.